So far we have derived that x is equal to this in terms of r theta and phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. We converted the xyz into r theta phi with the help of this, and then r we write in terms of xyz. Similarly, theta we write in terms of xyz, and phi we write in terms of x and y because it is planar in nature. Then we calculated the r unit vector in terms of the x, y and z unit vectors. Similarly, theta in terms of x, y and z unit vectors, and phi in terms of x and y unit vector because this phi is in the plane of x and y. Now the question is that can we write, this is also problem 1.37, this is also problem 1.37 in which we do these things. So the question is here that can we write x, y and z unit vectors in terms of r theta and phi, as we have written the r theta and phi in terms of x, y and z unit vectors. So can we write the opposite of it? So yes, we can write. Now here if I look at these equations, then let's say this is equation 1, this is equation 2, and this is equation 3. Then we know here that this one is sine theta cos phi, then this is cos theta cos phi. Similarly, the other terms. So we will have to multiply them with sine theta or cos theta or sine phi or cos phi. Then we will eliminate the, for example, if we want x here, so we will have to eliminate y and z. So to do this thing, let's multiply equation 1 by sine theta. So multiply equation 1 by sine theta. So when we multiply it by sine theta, we get sine r unit vector sine of theta is equal to, this will become sine square theta cos phi and x unit vector plus sine square theta and sine phi and y unit vector and sine theta cos theta and z unit vector. And we multiply equation 2 by cos theta in order to do some cancellations. So this will be equal to theta unit vector and cos theta equals, multiply this with cos theta, so it will be equal to cos square theta cos phi and x unit vector plus cos square theta and sine phi and y unit vector, and minus, it will become sine theta cos theta in z unit vector. And now let we add these two, means adding these two will give us, I can write here, this will be equal to sine theta in r unit vector plus cos theta in theta unit vector, and this will be equal, this I can write, this plus this. If I take cos phi is common, then sine square theta plus cos square theta will come out to be 1. So I can write that this is equal to cos phi in x unit vector, because sine square theta plus cos square theta will come out to be 1, plus if I take sine phi is common, then sine square theta plus cos square theta will again come out to be 1. So I will write sine phi in y unit vector. And now what about these two? They are cancelling here. So we got only this thing, cos phi in x unit vector, sine phi in y unit vector. And now if I look at equation 3, then here I am having minus sine phi in x while plus cos phi in y. So I will say that multiply equation means I need x here. So I will multiply equation 3. Multiply equation 3 by sine phi. So multiply equation 3 by sine phi and add with this one. So we will write here, so sine phi, and this will be equal to sine phi, and phi unit vector is equal, this multiply with sine phi, so it will become minus sine square phi and an x unit vector plus, as I am multiplying with sine, so this is sine phi cos phi in y unit vector. And now let me multiply this one with cos phi. So this equation, if I multiply this equation with cos phi, both sides, then I will have sine theta. I will have sine theta cos phi, means let me write here sine theta cos phi, and an r unit vector plus cos theta cos phi and theta unit vector is equal to cos square, means I am multiplying with cos phi, so cos square phi and x unit vector, and plus sine phi cos phi and y unit vector. And then let me subtract these two from each other, because I want cancellation of this term and want to keep this term. So then means subtract this equation from this equation, this equation. So what it will be? It will be sine theta cos phi in r unit vector plus cos theta cos phi and theta unit vector minus sine phi and phi unit vector is equal to, now this will be cos square phi minus becomes plus and sine square phi. So cos square phi plus sine square phi will be equal to 1, and it will come out to be x unit vector. And when this one becomes minus, so these two will be cancelling, and means when this is minus here, these two will be cancelling, and we have that thing equal to 0. So what we have done, we have converted successfully x unit vector in terms of the r theta and phi unit vectors. So this is what we wanted. And now we will do the reverse here, and that thing is that we have this term, this one, and now I would like to cancel this one, to cancel this term, and just mark this value, means I need now the y unit vector. So for this, now let's say this is equation, let's say we up to equation 3, so let's say this is equation 4 and this is equation 5. So this is equation 5. With this we have multiplied this with sine phi here, and we will just take it from here. So now multiplying equation 4 by, we multiply equation 4 by sine phi now. Earlier we did it by cos phi. So now multiply this equation 4 by sine phi, and we will get sine theta sine phi in r unit vector plus cos theta sine phi in theta unit vector is equal to sine phi cos phi in x unit vector plus this will become plus sine square phi in y unit vector. And we multiply equation 3 by cos phi. Multiply equation 3 by cos phi, and it will come out to be cos phi equals means cos phi here and phi unit vector, this is equal to minus sine phi cos phi minus sine phi cos phi in x unit vector and plus cos square phi in y unit vector. And now we add these two. And now it is clearly visible that these two terms are cancelling, and sine square phi plus cos square phi, this will give us 1. So we will have y unit vector is equal to sine theta sine phi in r unit vector plus cos theta sine phi in theta unit vector, cos theta sine phi in theta unit vector, and as we have added, so plus cos phi in phi unit vector. And with this we have found the y unit vector as well. Similarly, in order to find the z unit vector in terms of r, theta and phi, now for z unit vector we write here, if I look at this result, now here I want to keep the z unit vector. So to keep the z unit vector, I will have to multiply in such a manner that these cancel each other, this and this cancel each other, x and y unit vectors, while this remains with us so that we can calculate the z unit vector. So what we do, we multiply equation 1 by cos theta. We multiply equation 1 by cos theta, so it will be equal to cos theta in our unit vector is equal to sin theta cos phi. So it will be equal to sin theta cos theta and cos phi in x unit vector plus, this is cos theta, so sin theta cos theta, sin theta cos theta and sin phi in y unit vector, and plus cos theta, and here is cos theta, so cos square theta in z unit vector. Similarly, we multiply equation 2 by sin theta now, and it will come out to be sin theta unit vector equals sin theta cos theta, sin theta cos theta and cos phi in x unit vector plus cos square theta sin phi. So this is with sin theta, so sin theta cos theta, sin theta cos theta and sin phi in y unit vector plus, it's minus sin theta, and here we are having sin theta, so it will become minus, this is minus and sin square theta, and it is in z unit vector. Now here, as we are having minus sign here, so from this equation we will subtract this equation, and what will happen when we will subtract from this equation, then this sign will become minus, this sign is plus, this will become minus, this sign is plus here and this will become minus, and this sign will become plus here. So look here at the cancellations, sin theta cos theta cos phi, sin theta cos theta cos phi, it means this one is cancelling. Sin theta cos theta sin phi, sin theta cos theta sin phi, this one is cancelling, and cos square theta plus sin square theta comes out to be 1, so we are having z unit vector is equal to cos theta in r unit vector minus sin theta in theta unit vector, and z unit vector comes out to be two-dimensional in nature. So this is the way to convert an equation, means from the from the r theta phi unit vectors, we can convert this into x, y and z unit vectors in terms of the r theta and phi. Similarly, we know that there are some other derivatives are gradient, divergence and curl. We can convert them. For example, writing gradient in terms of spherical polar coordinates, writing the divergence in spherical polar coordinates, and writing the curl in spherical polar coordinates. Now the book is giving you some hints how to convert this one into the form in which you are having the involvement of r theta and phi. As we know, the gradient is curly by curly x and x unit vector plus curly by curly y and y unit vector and curly by curly z and z unit vector. But when we would like to convert this one into spherical polar coordinates, means the derivative should be with respect to r theta phi and the unit vectors should be r theta and phi unit vectors. So how we will be able to convert this one? The book is giving you a hint that how you can write the gradient first and then how you will be able to convert this one, while in appendix A it is giving you some direct ways to remember this thing and to do these calculations very easily. These calculations have already been done in the George Ofken mathematical methods of physics, as well as you can have these calculation in a detailed way online in Mathematica Wolfram. In Mathematica Wolfram, you are having these calculations. So from there you can practice with gradient, divergence and curl and how to calculate them. This means the gradient will take almost an hour to do these calculation, and similarly the divergence and gradient. And we can then, when we will do the cylindrical polar coordinates, we can convert into the cylindrical polar coordinates. So the Mathematica Wolfram will give you all the calculations. You can check them online. In this lecture, we will not derive them, because it doesn't matter you calculate these things in a Cartesian coordinates or in a spherical polar or cylindrical polar coordinates, the result will be the same. The only thing is that calculation will become easier with this. So as assignment you can do these conversions.